So here we have the 70th exercise of the list that you have in the virtual campus, and I chose this exercise because the explanation is quite long, and sometimes this may, scare some students. But I just want you to see that if we read carefully, the exercise is not more difficult than others. So we are going to do it. Here we have to design a minimum digital system on two levels. That means that we have to look for the minimal sum or the minimal product and use an OR level or an level to build the logic circuit. So now we are going to read the exercise. We have to control the traffic lights of three roads that converge into one. So we have three traffic lights that controls the traffic of the cars that converge into a new main road. So if the traffic light is 1, is going to be red, and if it is 0, and if it's 0, is going to be green. So we have sensors in each of the roads, and the sensor detects if we have cars or not. If the sensor are 1, we have cars. If the sensor are 0, we have no cars. Besides, we have two switches that establishes a series of rules. So we are going to study the input and the output to build the truth table. So I'm going to go to the notebook. So we have 5 inputs that are the traffic light sensor, the car sensors of road A, B, and C that are going to be 1 if there is if we have cars, and they are going to be 0 if there is no cars, and the three of them work the same. And we have switches as well. So we have function of 5 variables. The output are going to be the traffic lights. The traffic light of road A, road B, and road C. 1, the traffic light is red, no cars passing. 0, the traffic light is green, and the three of them work the same. So we have this main road and 3 roads that converge into it. So this is going to be, for example, A, B, and C, the 3 sensors, and here we are going to have the traffic lights of each road. So note that this may be a real application of a crossroad as the ones that we can find in Malaga or any other city. This is a real application of digital systems. We can find this kind of digital circuit in real traffic lights. So our inputs are going to be the switches and the sensors of each road. Note that the truth table have 32 combinations because we have 5 variables. 5 is 2 raised to 5, 32 combinations. So I have divided the truth table in 2 halves because otherwise I didn't have enough space. But it's like having a truth table in the same way we are used to. It's just the same. And the output are going to be our traffic lights. So how do we complete the truth table? We are going to look at the exercise. So we have 4 rules, A, B, C, and D, and they have priority. So A is going to have a higher priority than the rest of the rules. So it's going to be like this. So we are going to start applying the rules in this order. So the first rule is that if we have this combination of the switches, all the traffic lights has to be red. Red is 1. So all the traffic lights have to be 1. So we are going to look for this combination in the table, in the truth table. Both switches are 0. Both switches are 0 in this case. Here, 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 and here. So for all these inputs, we have that the traffic lights are green. Green is that they are 0. So here we have, 0 in all these cases. Because we apply rule A. Okay, we are going to continue looking at the rules. The following rules if this B, rule B. So if there is no car on any road, all the traffic lights must be green. If there is no car, we have 0 in all the sensors of the roads. In this case, all the traffic lights has to be green, so they have to be 0 because 0 means that the traffic lights are green. So we are going to look again for these combinations. I'm going to choose another color. So we have that we accomplish this rule here, here for example, here and here. So in these cases, just remind that the traffic light has to be green, and green is this is red. Okay, this is not good. Green is 0. So let's do it. In fact, in this case, in the first case, we have that the output should be 1. So I made a mistake. I'm going to correct it. Okay. Just let me to correct this, because red is 1. For me, it's quite unintuitive. So when there is no car, the traffic light has to be green, and green is 0. So in these cases, the traffic lights are 0 due to rule B. So now we are going to see what happens with the next rules. For example, rule C. If there is cars only on one of the roads, they should be allowed to pass, and the other road has to be set to red. So if there are if there are cars only on one road, this traffic light is going to be green, and the other 2 roads are going to be red. So we are going to look for the situation in which we have cars only in one of the roads. For example, here we have all the roads in C, here in B, here in A, and here in C, in B, in A, in C, in B, and in A. I don't see more situation like this. So this is going to be rule C, rule C, rule C, rule C, rule C, and rule C, rule C, rule C. Remember that green is 0 and red is 1, so we have to open the road in which we have cars. So in this case, we have cars in the C. So the C is going to be green, and the others is going to be red. If you paid attention to this, we have that is just the negation of this combination. So we are going to be fast taking that into account. So now we proceed with the last rule. So the last rule applies when we have cars on 2 or more roads. In this case, there is certain priority between the roads. So we are going to look for every combination. If we have this combination in the switches, this is going to be the priority C, B, A. So we are going to look for this combination 0, 1. 0, 1. We are here, here, in these 8 combinations, and we have to fill the gaps because the other gaps that are already complete has been complete due to rules with higher priorities. So we only complete the gaps we find. So in this case, we are going to have this priority. Sorry, it's like CBA, if I don't remember bad. CBA. I'm going to check it. Yes, CBA. So in this case, C is in this case, C, we have car in C, so C have to be open and the rest closed. So rule D1. And in this case, we have cars in C, so C is going to be opened and the rest closed. Rule D1. In this case, we don't have cars in C, but we have cars in B, and B is the following in the priority, so we are going to open B road. In this case, we have cars in the 3 roads, but C has priority. So we have completed this rule. So now we look at the following combination. When we have the combination 1, 0, the priority is going to be this in the road. So we come back to the table, and the priority is going to be like this when the switches are 1, 0. 1, 0. We locate these combinations in the table. 1, 0. We are here in these 8 combinations. So here there is no cars. Here we are here. There is no car in A, but we have car in B that has higher priority than C, so we are going to open B. Here we have cars in A, so we are going to open A. Here we have cars in A, so we are going to open A. And here we have cars in the 3 roads, so A has priority, so we open A. So we have finished with this combination, and we are going to look for the last rule. In the last rule, the switches has these combinations, and this is the priority B, A, C. So the priority is going to be B, A, C, and we are in these rows when both switches are 1. So we are going to start with the combination in which we have cars in B. We have cars in B here, so we have to open B. We have cars in B here, so we have to open B. And we have cars here in B as well, so we are going to open B. And in the remaining combination, we don't have cars in B, but we have cars in A. That is the second with the highest priority, so we are going to open A. So we have already finished the truth table. I'm going to complete this, rule D4, rule D4, and this was rule D3, rule D3, rule D3, rule D3. So we have the truth table. So now we proceed in the way that we already know. We are going to build the functions SA, SB, and SC, just translating the ones of each columns into a Karnaugh map of 5 variables. So we are going to have 3 Karnaugh maps of 3 variables, and we are going to look for the minimal sum or the minimal product of the 3 functions, and we proceed as in the method we know. So you have seen that it's been quite simple. It's just reading the exercise and translating the information into the truth table. So I'm not going to do any more of the exercise because it's long, but you know how to proceed in this case.